we want to write the equation of a line that is perpendicular to this line here. Y is 7/5 x plus 6, and it passes through the point 2, -6. So let's rewrite this equation. And the line that we're looking for is perpendicular to this one. And remember that perpendicular lines, their slopes are negative reciprocals of each other. So let's say this is line 1 and we're trying to find line 2. And the slope, if you remember slope-intercept form, we can compare it to this since m, the number multiplied by x, that is the slope of the line. In this case, the number multiplied by x is 7/5. So the slope of line 1 is 7/5. Now, the slope of our line, this perpendicular line, will have a slope that is the negative reciprocal of this. Or in other words, we can write that the slope of m1 is the negative reciprocal of the slope of m2. So we want to take this fraction, flip it over, and then make it negative. So we can say that the slope m2 is minus 5/7. So we just flip the fraction and make it negative to find the slope of a line that's perpendicular to that. So now we have the slope, and there are two ways to approach this. If we want, we can use slope-intercept form, or we can use point-slope form. So if we want to use slope-intercept form, we would start by writing out what we know about the equation of the line. This would be y2 is equal to minus 5/7x plus b, since we don't know our y-intercept. That's what we can figure out with this point. From here, what we can do is take our point and plug it in what we know for x and y. So for instance, we know that it goes through x is equal to 2 and y is equal to -6. So if we plug both of these in, we can then solve for b and rewrite our entire equation. So that is one approach. The other approach is to use point-slope form. And remember, point-slope form is when you know the slope and you know some point on the line. And let me actually just call this x sub a and y sub a, since we already used the subscript of 1. And from here, our point slope would be y minus y sub a is equal to m times x minus x sub a. So if we know a point, we can just plug it into this point slope form and then just solve for y. So both of these approaches are valid. So it depends what you feel more comfortable with or what you remember. Not everyone remembers point slope, but it is a useful thing to know since it comes up often that you know the slope and you know one of the points. So let's use point slope form. But like I mentioned, this is perfectly valid. Just plug in x and y and then solve for b and then rewrite this equation with your knowledge of what b is equal to. So we're going to plug in for our known x and y values and our known slope. So we know that we have y minus the y value of our point, which is -6. Be careful with your negative signs here. We are subtracting whatever that y value is. In this case, it's negative. So we're subtracting a negative, so in the end, we're going to add these. And we have m, which is minus 5/7 times x minus the x value of our point, which is 2. And with the Khan Academy exercise, you can actually just submit this as the answer, but let's solve it for y. So this is really y plus 6, and we'll distribute the minus 5/7, so we get minus 5x over 7, and the negatives cancel when we multiply here, and we get 10/7. Now to solve for y, we'll have to subtract 6 on each side, so let me just make a little bit more room to do that. And we can work over here. So y is equal to minus 5x over 7, and we subtracted 6. So we have plus 10/7, and instead of writing it as -6, I'm going to give it a denominator of 7, and 6 times 7 is 42. So we're subtracting 42/7, which is the same thing as subtracting 6. So our final equation then would be minus 5x over 7, and 10 minus 42 is minus 32. So we get minus 32 over 7. So this is our missing equation that is perpendicular to the given equation, and it passes through this point.